Hey there! So, let's talk about an interesting problem that you might encounter when working with FFT in Python. Have you ever wondered why the values obtained from the inverse FFT of the element-wise multiplication of two FFTs are different from the result of convolution between two arrays? It seems like a bit of a mystery, right? Let's delve into the solution now. The issue lies in the fact that FFT uses circular convolution as opposed to linear convolution. To tackle this, we can employ zero padding before performing FFT to align the results with linear convolution. The provided code snippet showcases how to achieve this by padding the input arrays appropriately and then carrying out FFT operations to compute the convolution. This adjustment ensures that the outcomes match those obtained through linear convolution. Continuing on the solution path, the code snippet furnishes the results of the corrected FFT operation after zero padding and the conventional linear convolution between the input arrays. By employing zero padding to harmonize the circular convolution approach of FFT with the linear convolution method, we successfully achieve consistent results that mirror the outcomes of standard convolution operations. This alignment helps in utilizing FFT effectively for convolution tasks and ensures accurate computations. In summary, by understanding the nuances between circular and linear convolution in FFT operations and implementing zero padding to mitigate the disparities, we can attain consistent results akin to traditional convolution processes. It's all about bridging the gap between circular and linear convolution methods to enhance the accuracy of FFT-based computations. Well, that's all for today. Remember to subscribe, like the video, and drop a comment below. Until next time, happy coding!